Good morning, AOBI. This is Mr. Dunning. Stand by. I have a math lesson for you. Okay. Beginning with this circle, we're going to draw a line that touches the circle in exactly one point. That line has a name. It's called a tangent. The next piece that we're going to look at pokes right through the circle. It intersects the circle in two places. That piece is called a secant. The piece of a secant inside the circle has its own name. This piece here, inside the circle, is called a chord. So we've learned three new names: tangent, secant, and chord. We've used this term before, but now you know what it is. It's the piece of a secant that's inside the circle. Now, one of the questions that is almost bound to pop up on exams is, what is the longest possible chord? Well, common sense is going to tell you it is the chord that passes through the center of the circle. And you know that is its very own name. That is called a diameter. In this lesson, we're going to learn about angles that are created when two tangents meet outside the circle, but they can't meet inside the circle, come on, or two secants meet outside, not outside the building, you goof, outside the circle. Come on. Or a tangent and a secant meet. All of those have relationships that we're going to look at today. The relationships all can be solved with one equation. One. I'm going to put that up here so that you can see it. The angle equals 1/2 the difference between the big arc and the small arc. This equation is the beginning point for all of the problems that you're going to see dealing with angles formed by two tangents, or a tangent and a secant, or two secants. If you begin with this equation, you're going to end up filling in the blanks and solving for the piece that you don't have. Easy. In this picture, we have two secants that got together out here, forming this angle. We're going to call that angle X. And we're going to say this arc here is 70, and this arc here is 30. And now we're going to plug those numbers in. Don't get creative, just plug the little suckers in. That is the big arc. Can you see it? The big arc, right there. So where I have big arc, I'm going to put the value 70. This little puppy here is the small arc. Can you see that? Are you good on that? Can you see that that's the big arc and that's the small arc? Now, once again, don't get creative. Begin with the basic equation and put in the numbers. Now, quickly, can somebody tell me, anybody, is there anybody out there who can tell me what 70 minus 30 is? Well, if you do arithmetic, you're going to come up with the same number I come up with, and that number is 40. The difference between 70 and 30 is 40. Half of 40 is 20. That's right. So this angle here that we were looking for is 20 degrees. In example 2, what we're going to do is draw this happy little tangent here and that secant right there. And once again, we're going to be looking for the size of that angle. Okay? So, we're going to replace the angle with the dreaded X. And now we need information. So I am going to make this arc 110, and I'm going to make this arc 70. Don't get creative. Use the basic equation. That's your beginning point. The big arc in this is 110. The small arc is 70. The difference between 110 and 70 is 40. So, 40 would go in here. Half of 40 is 20. So this X here is 20. This angle X out here is 20. Now the picture that trips up quite a few people, for some reason they get all sideways to it, is where instead of having two secants, or a tangent and a secant, the picture has two tangents. So, we're going to draw a picture of an ice cream cone, about to lose the ice cream, where we have two tangents and the angle, again, the dreaded X. Don't you love X's? Now, in this picture, we still use the same formula. Now, unless you reside on some other planet, I think you can see that the big arc goes around this way. That's what? I said it wrong? Oh, that's, oh, I got the color backwards. We can fix that. And by the way, I'm glad that you were looking to pick that up. Thank you. The big arc is over here. This one. And the small arc is here. This one. Same formula. Now you need to be just a little bit cautious to be sure that the big arc, the green piece, and small arc, the red piece, add to 360 because that's the whole circle. So let's put in some numbers here. Once again, I am urging you, when you do these problems, don't get creative. Use your formula and put in the values. In the picture, the big arc is 230. And the small arc is 130. The difference between 230 and 130, come on now, 100, that's right. Half of 100 is, you got it, 50. So this angle here is 50. This formula is what you use when you have two secants, a secant and a tangent, or two tangents that meet outside the circle. In example 4, what we're going to do is change the problem just a little bit, not very much. We're going to tell you that this angle here is 26 degrees, and that this arc over here, this one, big one. Can you see it? It's the big one. Is 90. And the question now is, how big is that little piece of art? How many times have I said it? Once, twice, three, half a dozen times. Use the formula. The angle is 1/2 of the difference between the big arc that would be this one, and the small arc. That would be this one. Now we're just going to put those values in and then solve for x. The big arc, 90. The small arc, x. We don't know it yet. That's what we're looking for. But put that little hummer in the equation just like that. The angle, we know, is 26. And now, all we have to do is solve for x. One of the tricks in algebra that's very helpful is to clear fractions. So I'm going to multiply both sides, in fact, the whole equation, by 2. Multiplying by 2 gets rid of this nasty little 1/2. And it leaves me, on this side, 52 is 90 minus x. Got it? Now, if negatives scare you, we can move the x over here, but if they don't worry about it. We're going to subtract 90 from both sides, and on this side, we'll have minus 38, and on this side, minus x. Multiplying both sides by minus 1 gives us 38 is x. So this piece here, that arc, is 38. In review, we said the angle when two tangents meet, or two secants meet, or a tangent and a secant meet outside the circle, can be found with this formula. It's going to be, the angle is 1/2 the difference between the big arc and the small arc. When you run into these problems, I encourage you to begin with this basic formula. Plug in the values that you have and solve for the one that you don't. A preview of what's coming tomorrow. Simple. I have been talking to you now for 3 days about central angles, inscribed angles, and these new ones where the vertex is outside the circle. We're going to talk about these angles with a vertex inside the circle, but not at the center. The picture of this little puppy would look like this: two chords that cross inside the circle. These angles, all four of them, have a vertex in the circle, but not at the center. And we'll learn how to solve those tomorrow.